Hello friends, this is Manika from Gyanodaya Academy. The topic for today's discussion is going to be trigonometry. We are going to be restricting ourselves to right angle triangles, and in a right angle triangle, if you have a right angle triangle ABC, right angled at base, right angled at B, and let's say theta is the angle at C, then what we are going to call is, we'll call AB as the perpendicular, BC as the base, and AC as the hypotenuse. So there are 6 trigonometric functions, which are basically the sine function, the cosine function, the tangent function, the cosecant function, the secant function, and the cotangent function. So, and these are for a given value of theta. So let's say we talk about sine theta. This is written as cos theta, tan theta, cosecant theta, sec theta, cot theta. And you may have watched that movie Nilbata Sannata, where they actually talk of this, and they say that Pandit Badri Prasad Har Bhole Sona Chandi Tole, Sona Chandi Tole. So this is nothing but perpendicular is AB over hypotenuse is AC, base is BC over AC, perpendicular over base will become AB over BC, right? And cosecant theta is nothing but 1 by sine theta, so it becomes hypotenuse over perpendicular, which is AC over BC. Secant theta is 1 by cos theta, which will become hypotenuse over base, which is nothing but AC over AB. This is AC over AB, and this will be AC over BC. And cot theta is 1 by tan theta, which will be essentially your base over perpendicular, which is BC over AB. So using Pythagoras theorem, what we also get is a very important formula, which is sine squared theta plus cos squared theta is equal to 1, and dividing the numerator and denominator either by sine theta or by cos theta, we would derive these two formulae also, that tan squared theta equal to secant squared theta, and 1 plus cot squared theta is equal to cosecant squared theta. These formulae are very important when we have to solve trigonometric identities. Besides this, what we need to remember is tan theta is nothing but sine theta over cos theta. Okay, so this is the basics, and then you also have in your course what is called some of the trigonometric values that you need to remember. And I will here first demonstrate a very easy way of remembering it. So you have these 0, 30, 45, 60 and 90. So what I do is I write 0, 1, 2, 3, 4, and I divide each of them by 4. 1 by 4, 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 and take the under root. So it is the under root of all this. So this is 0, this is 1 by 2, this is 1 by root 2, this will be root 3 by 2, and this will be nothing but 1, right? And if I take the in an inverse manner, so cos 0 is nothing but cos 90, which will be 1. Sine 60 is nothing but cos 30, which will be root 3 by 2. This will be 1 by root 2, and this will become 1 by 2. Okay, so let me just rewrite it in a fresh page, and what we will now get is, once you have memorized it, we can derive these things. This is 0, 30, 45, 60 and 90. My sine is 0, half, 1 by root 2, root 3 by 2, and 1 cos 0 is 1, root 3 by 2, 1 by root 2, half, and 0. Tan theta we know is sin theta over cos theta. So essentially I'm going to be dividing this by this, which is 0. This divided by this will be 1 by root 3, 1 root 3, and this will be 1 divided by 0. So we say it says not defined. So what we have is we have looked at what really the formulae and the bases are, and then we need to remember these ratios to solve some of the problems. What we also have in our course are the complementary angles, which is essentially saying that sine of 90 minus theta is cos theta, cos of 90 minus theta is sin theta, tan of 90 minus theta is cot theta, secant 90 minus theta is cosecant theta, cosec 90 minus theta is sec theta, and cot 90 minus theta will be nothing but tan theta. So based on this information we will be doing a few questions. So let's say example 1 is we are given if 5 tan theta equal to 4, we have to find the value of 5 sin theta minus 4 cos theta divided by 5 sin theta plus 4 cos theta. So there are two ways of doing it. So essentially what we are given, of course, is tan theta is equal to 4 by 5. So there are two ways of doing it. One, what you can do is draw a rectangle. We know tan theta is perpendicular over base. So it's like perpendicular is 4k, base is 5k. Perpendicular over tan theta is 4 by 5. So this is ABC, and then what we get here is this will be nothing but 25 plus 16, which is 41, root 41k, right? And based on this, what you will get is sin theta is perpendicular over hypotenuse, which will be 4 by root 41, cos theta will be 5 by root 41, and substitute the values of sin theta and cos theta in the equation, right? So the alternate way of doing it is also, so alternatively I can divide 5 sin theta minus 4 cos theta by 5 sin theta plus cos theta, 4 cos theta. I divide the numerator and denominator by cos theta. So what I get is that this is equal to 5 tan theta minus 4 divided by 5 tan theta plus 4. And when I put the values of substituting for tan theta equal to 4 by 5, I get this will be equal to 4 minus 4 by 4 plus 4, which will be 0, right? And so you can do it in two different ways. Now let's look at the second question. So question 2 is we have to prove the identity. So cot theta minus cosecant theta whole square equal to 1 minus cos theta by 1 plus cos theta. So when we are proving these identities, what we are really going to be looking for is we'll be using, whenever we will begin from left hand side or one of the sides and prove it is equal to the other side. Now what I notice here is that you have these cot and cosecant in the left hand side, while in the right hand side you have the answer in cos theta. So what I will do is I will first begin with this, and I'll say that this is equal to cosecant squared theta. I convert it into sine and cos. So this is nothing but cos theta by sine theta minus 1 by sine theta whole squared, which is nothing but I can say it as 1 minus cos theta whole squared by sine squared theta. I have changed deliberately 1 minus cos theta because it's a square thing. So 1 minus cos theta whole squared is the same as cos theta minus 1 whole squared. And I know that this is equal to 1 minus cos theta whole squared divided by 1 minus cos squared theta. So the identities that are going to be used here, we have done sine squared theta plus cos squared theta equal to 1, which means that sine squared theta can be written as 1 minus cos squared theta. And now using the identity a squared minus b squared is equal to a minus b into a plus b, I can write this as 1 minus cos theta whole squared divided by 1 minus cos theta into 1 plus cos theta. And this gets cancelled and I'm left with 1 minus cos theta by 1 plus cos theta, which is essentially my right hand side, and hence I proved it. So things to remember is, one is that we look at the right hand side and take hints, or take it should be able to provide you with some suggestions, right? Take suggestions as to how to proceed. So if it like here in this case, it was that the right hand side was in form of cos while the left hand side was in form of cot and cosecant. So first is maybe converted into sine and cos, right? Second is these identities, a squared minus b squared equal to a minus b into a plus b, and more so a cube minus b cube is a minus b into a squared plus b squared plus ab, and a cube plus b cube is equal to a plus b, a squared plus b squared minus ab. These will be required. These are important identities. And of course, I don't need to say that sine squared theta plus cos squared theta equal to 1, which is the same thing as saying sine squared theta is equal to 1 minus cos squared theta, or cos squared theta is equal to 1 minus sine squared theta would be required. If you see, suppose you see you have in some questions you have secant theta plus tan theta or something like that, and then you can think of what should come to your mind is applying the identity somehow that 1 plus tan squared theta is equal to secant squared theta, because you can multiply this by secant theta minus tan theta, and divide by secant theta minus tan theta. So if you do the same operation, it will really not matter, right? So these are certain hints that you have to use this identity. This comes handy. It depends upon what your left hand side and what your right hand side are. That should give you some clue as to how to proceed, and these identities are very often used in such questions. We go to the next type of questions, which is at times asked, is find the value of. So let's look at this question. 3 cot squared theta, 3 cot squared 60 plus secant squared 45. So you would recall that we had drawn that table, right? And we knew that tan 60 is tan 60 is root 3, which means cot 60 will be 1 by root 3, and we knew cos 45 was 1 by root 2, because this table you need to remember, right? Which would imply secant 45 would be root 2. So substituting these values, we would get 3 cot squared 60 plus secant squared 45 as 3 into 1 by root 3 whole squared plus 1 root 2 whole squared, which is 3 into 1 by 3 plus 2, which is 1 plus 2, which is 3. Okay, so the fourth type of questions are which involve complementary angles, right? So what we did is that we have these complementary trigonometric functions, which gives us that cos 20 will be the same as sine of 90 minus 20, which is sine 70, and similarly cot 25 is tan of 90 minus 25, which is tan of 65. Similarly, you can find out that cot 5 is nothing but tan 85, cot 10 is nothing but tan 80. And when we substitute these in the given equation, let's say in 1, we get that sine squared 70 plus cos squared 70 plus tan 65 divided by tan 65 plus cot 5 into cot 10 into 1 by, cot 60 is nothing but 1 by root 3 into tan 10 tan 5. So we know that sine squared theta plus cos squared theta is 1. So sine squared 70 plus cos squared 70 is 1. This will get cancelled and we get another one. Now cot 5 will get cancelled with tan 5 because cot 5 is essentially 1 by tan 5. Similarly, cot 10 will get cancelled with tan 10. So we will be left with 1 by root 3. So the answer is 2 plus 1 by root 3, or if I rationalize, 2 plus root 3 by 3, or 6 plus root 3 by 3. So this is the answer that is required. So these are 4 kinds of problems that we did today, and which more or less, there will be some numbers like this which will be coming. Of course, the difficulty level in some of them may be much higher. So in case you have any questions, please put them in the comment box. If you have any recommendations or suggestions as to which chapters you would want me to cover first, please let me know. I will accordingly prepare my videos and get back to you as soon as possible. The next video would be on applications of trigonometry, and we will again be solving a few problems which the kind of problems which are expected in the boards. Okay, all the best.